So let me say that the purpose of finding instant centers is to use them to perform graphical velocity analysis using instant center 1, n. So you have to identify an instant center that is locked to ground, and that way you're able to find the velocity of a point, and from there you're able to make ratios between your angular velocities. I'll show you what that means.
So we should have just only found 10 just now, right?
Yeah.
Okay, I'm counting 11 that we did. Okay. It's probably me labeling something twice.
Let's see.
No, it's
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
I'm counting 10 in there until the next one. Mine is 11. I'm not sure.
Yeah. All right, so let's go ahead and show you what I mean here. All right, so I know that this right here is I12. Because this is body 1 and this is body 2. And if I have a point here, A, I know that if I draw a line from 1, 2 to A, and say my angular velocity is like this here, then I know that A is moving like this, perpendicular, so that this is the velocity there. So we're going to use that information. And I can also write this, that the velocity of A, just the magnitude of it, is equal to omega times I12 point A. And so that's my own notation. You won't see that in the book. So the parentheses I12 arrow A is the notation that we just used in this class. So let's apply this here. As an example, here's a 4-bar graphical velocity analysis. You'll be given omega 2, which is your input angular velocity. What you need to find is omega 3 and omega 4. Okay. Let's go ahead and draw a 4-bar here. And we'll apply this to a numerical example after this, but let me just set it up here and show you how it works. It doesn't necessarily have to be horizontal to grounds. Is that what you're asking? It doesn't have to be. Okay. So we have 1, 2, 3, and 4. So the obvious ones are I12, I14, I23, I34. And the non-obvious ones, if I draw a line through 1, 2, 1, 4, okay, and I draw a line through 2, 3, 3, 4. If I look at this, the common is 3, uncommon is 2 and 4, common is 1, uncommon is 2 and 4, so where they intersect is I24. Okay. And then for this one here, if I have a line here, and a line here, the common is 2, 1, 3 is uncommon. The common is 4, uncommon is 1, 3. So this line really should be right here. Okay. That's I13. All right. So that's all the instance centers for a 4-bar. And if you're given that omega 2 is going like this, this is what you do. You have a point here, A, and you have a point here, B. So A is where 2, 3 is, and B is where 3, 4 is. All right. So there's a general formula that I want to give you. Is omega n comma m. Let me do it now. Omega m comma n equals omega m times I1 m to I m n, which equals omega n times 1 I 1 n to I m n. Let me zoom up on that. So let me repeat that. Mn equals omega m, parentheses 1m to mn, equals omega n, parentheses 1n mn. All right, and I'll show you what I mean by that. So, for the velocity of A, and this is just magnitude, velocity of A equals the velocity of I2, 3, which equals omega 2 times I1, 2 to I2, 3, which equals omega 3 times I1, 3 to I2, 3. So what you do here is you measure this distance here, put that in there, measure this distance here, put that in there. We're given the magnitude of omega 2, so we solve omega 3 from this.
So why are those VA and VI 1, 2, 3, why are those not omegas?
they're linear velocities. The v's are linear velocities.
But I thought in the equation you gave us was that it was the angular velocity that was equal to that.
It is. So this right here, I can actually, if I write this thing out here, so you probably want to see something like this, the velocity of I and N. Like that? So let's go find the velocity of B. That equals the velocity of I34, which equals omega 3, I13, I34, which equals omega 4, I14, I34. And then this allows you to solve for the magnitude of omega 4. Because you get omega 3 from this part, you measure 1, 3 to 3, 4, you measure from here to here, you measure from here to here, and then you solve for omega 4. Right? Now there's a way to check on this too. So this little point out here, the velocity of I24, the velocity of I24 equals omega 2 and I12 to I24, which equals omega 4 I14 to I24. So that's a way to check your omega 4 result from the previous one. There's no way to do it for omega 3, but there is, in this case here, a way to check to see if your omega 4 matches up. Okay? Now again, this is graphical. So there's going to be a little bit of inaccuracy to this, but it's going to be pretty darn close if you're careful in your measure. All right?
So when you do like I13 to I13 to I34, do you just need the length
Right.
between them?
The distance between the points.
So you can draw all this omegas on that graph, right?
Yes. So let me go ahead and do that. So what you're going to do here, for direction, you have to observe. So let me put that down. Need to observe linear velocity directions and angular velocity directions. So what I mean by that is, let me zoom up on this again for a second. So if I'm given omega 2 going like this, okay, it's going like that, what is the direction of the velocity of A? So the velocity of A is perpendicular, right? So you have to lay that thing down here. So this is the velocity of A. So I can calculate the magnitude of it using this right here, all right? And then knowing what theta 2 is and rotating it 90 degrees and adding 90 degrees to it, I can get the direction. Okay? So that's going like that. Now you have to think of anything that has a 1 as a subscript is an instant graph. Now on this right here, 1, 2, and 1, 4, they always stay in the same location, but 1,3 is constantly moving. But at this snapshot in time, this instant in time, you can think of this thing here as a ground location. All right? So, because I know that the velocity of I23 is going like that, 2,3 is associated with omega 2 and omega 3 because it has a 3 in the subscript. So omega 3 is this right here. In order to drive this thing this way, my omega 3 is negative. Okay? So in this example here, observe omega 3 is negative. Okay?
How did you determine that again?
All right, so let me look at it again. This point here is I23, happens to be the same thing as A. I23 is influenced by omega 2 and influenced by omega 3. I know that from the given of omega 2, and I'm curling this way, I know that the velocity of I23 goes up like that. Looking at I13, which is my instant ground, in order for this point to go in the same direction, you have to stick your thumb into the page and curl your fingers like that, so it's negative. Okay? All right, so now, knowing that this is going this way, the velocity of B is going like this. All right? Has to be perpendicular to this. So if that's the case, what is my omega 4? So if I'm driving this thing here, so here's my omega 3 forcing this thing this way. Omega 4 has to be moving what direction? Going positive, isn't it? So this is my omega 4. So, if you look at this here, you observe omega 4 is positive. All right? So the nice thing about these instant centers is you don't have to grab any calculator or any equation. You can just look at this and say, hey, here's I13, this is going this way, so omega 3 is negative. That's driving this bar this way. So you know if I'm going like this is going like that. The other clue is right here. I24 is going straight down. So let me zoom up on that. The velocity of I24 is going straight down. Okay? So if I know that omega 2 is going like this, driving this point down, then I just need to walk over to omega 4 and go, ah, omega 4 is positive also, in order to drive that thing down. Okay? So that's what you look at. All right.
So it looks like that you have like the velocity I23 in that. Is 2 and 3 always going to be in opposite directions when you're looking at how that velocity is?
Just 2 and 3. No. I can't make that statement. Okay. What else on this? Because now we're going to do a numerical example. Okay, so what I did was, there's a handout that's been on Blackboard, but I didn't anticipate everyone would have it with them, so I printed it out. It's a two-sided handout. So on this side here is the 4-bar. You can draw on this, and then this side here is the crank slide, so make sure you bring this on Monday too. Let me just kind of hand it out.
So we're doing your work now.
And if you didn't get one, there's one there. Okay?
Thank you.